Okay. So hello everyone. Today we are going to solve another GFG problem of the day. Today's question is stock buy and sell with cool down. Coming to the problem statement, given an array where the ith element of the array represents the price of a stock on the ith day, all prices are non-negative integers. Find the maximum profit you can make by buying and selling stocks such that after selling a stock you cannot buy again on the next day. So there will be a cool down period of 1 day. Okay. So if I refactor the question, we have been given an array. Okay. Let me draw it. So we have been given an array where the ith element represents the price of the at ith day. Now we need to buy and sell stock according to our need, such that we can maximize our profit by buying and selling the stocks. And there are two constraints, like before buying a stock, we need to sell the previous one. Like we cannot hold multiple stock at a time. If we can buy stock only after selling the previous one that we have holded. And also after selling a stock, there is a cool down period of 1 day. That means if I sell a stock on ith day, then I won't be allowed to buy the stock on I plus 1st day, right? I need to wait for this day, and I can only sell on I plus 2 day. Okay. So let me take an example of this array. So I can go like on the first day or the 0th day, I can buy this stock. So then I can move to the next day. If I want, I can sell them. Then I will check like the previous day I buy the stock was on a price of 3, but on the next day the price falls down. So the price become 1. So I may choose to sell it or I may not. It's totally depend on us. But for now, let's move to the next day. Okay. So now the day is 6. So I will just check, like I buy the stock on 0th day, that is on the price of 3. Now the price became 6, so I can sell it. So my net profit will be 6 minus 3 equals to 3. Now as I sold the stock on this day, that is 3rd day or second index, I am not allowed, according to the constraint, I will be not allowed to buy another stock on this day. So I will jump to the next day and I can choose to buy stock here. And I also may not buy any stocks. It's totally dependent on our choice. So if I buy it, then I will buy for rupees 2. Then I will move to the next day, and now I can sell it. That will my net profit will be from this transaction will be 2. So according to this, my net profit throughout this array is 5. Now the problem statement is by buying and selling stocks, keeping in mind the constraints, we need to maximize our profit. So how we can solve this? So basically, we can notice that either on any particular day, if I do not have any stock in my hand, right? So that is, if I don't have any stock, then I can on any ith day, let's say, yeah, on any ith day, I can either choose to buy a stock on this day, or I can just move to the next day. It's totally dependent on us. So if so there are some cases like if I do not have any stock, let's say case 1, no stock, and I am and in any particular day, I can either buy, that is buy, or I can just move forward. And there is a second case, that is case 2, when I have already bought a stock, that is on any particular day I have already buy a stock, so I have a stock in my hand. So when I have stock, then on any ith day or jth day, I can either sell that is sell the stock and calculate my profit, or I can just move forward, that I will not sell on that day, I will sell on any other upcoming days, move forward. So these are the cases that we can have, right? Okay. So actually, we can. The problem says that keeping in mind all the cases that on any day I can buy, I can move forward, I can sell, I can move forward. I need to calculate the optimal or the maximum profit I can make using these choices. So one of the solutions can be by trying every possible choice. Like from ith day, I will just buy the stock on this day, or I will not buy the stock on this day, or I can sell a stock on some jth day, or I will not sell that stock. By trying every possible combinations, I will try to look for the best solution. So the one thing that allow us to try every possible combination is basically recursive functions. Okay, so let me write the recursion for this thing. Let a function be f. So for the thing that we need, that on which day I am currently in. So let it be marked by something like position or I. And one also thing that I require is whether I am in the first condition or I am the second condition. That is whether I am in currently at ith day, whether I am in case 1, that whether I have a stock in my hand or I do not have any stock. Our options will change according to that, right? So if I don't have any stock, that is case 1, I can buy it. And if I have a stock in my hand that I've already purchased, I cannot buy another one. Need to sell. So another state I required is that whether I have a stock or not. So we can just handle it by 1 or 0. Like if let me have a variable like flag or something. If the value of flag is 1, then we can assign it that we have a stock. If the value of flag is 0, then we don't have any stock. We can buy it. Like we can have that. And another thing that I require is the array, or that is the different days that we are having. Okay, so let me write it straight. So we require our flag and array. Okay. So first thing first, let's write the base condition, that is if at any moment let n be the size of the array. Size of array at any moment, if my position becomes greater than n, then just return 0 because we cannot have any profit after that. Okay, so if I greater than equals 0, return 0. Okay. Now coming to the options. I've already mentioned that anytime we can have two options based on a flag, and flag is a variable that will store at which state we are currently. Either we are going to sell or we are going to buy. Let's have it if flag. That means the value of flag. Okay, let me write it. If flag double equals to 1, let assign it that we can buy. Right? We do not have any stock in our hand. We can buy it. Right? So now, if flag double equals to 1, then there are two things that we can do. Okay. We can either choose to buy. Flag once means that we can buy, but it's not compulsory for us to buy. We have choice. We have two choices. Either we can buy or we can move forward. So now what to do? We will just check for the maximum that will provide us. Whether buying gives us a maximum value or just moving forward provide us a maximum value. We need to check, right? So there are two things that we can do. That is, let's say int buy, that we are buying. We are buying. Another thing. What do we mean by buying? Buying means that our budget, let our current profit be 0. We are buying means that we are buying a stock for rupees X. That means our profit becoming minus X until and unless we are going to sell it. Right? Let's say my current profit is 0. I buy a stock for X, then I sell it for Y. And what will be my current profit? Y minus X. So until I sell this Y, sell the stock at a price of Y, my current profit will be only minus X. That means my current profit is going down by my value of X. That because we are buying a stock. So we can just by uh, by choosing to buy, we can actually subtract the stock value from our profit. That is, currently that will be our array of I. That means we are buying the stock with the price of array of I plus. So we will call the recursive function, that is f of I plus 1. Now, no. Here the value of flag is 1 means we can buy, but after buying, the value will tweak. The value will change. That means the flag value will be 0, right? Flag 0. If flag 1 represents buy, then flag 0 will represent sell. No, that means, okay, let me mention it clearly. 1 means buy, that means 0 means sell. As we are buying here, that means our flag value also need to change. That means that's for the next transaction we are going to sell. We cannot buy because we already have a stock in hand, that is ith stock, that we just buy using array of I value. Okay, so the flag value will change to 0, then we can pass. And if we do not buy, that is, if we not choose to buy, okay, color doesn't change. Yeah, that is, if we do not buy, it be d buy. That means we are not going to subtract array of I because our profit remains the same. We are not buying, we are not selling. That means we are only going to call the recursive function I plus 1. But here the value of flag will not change because as we are not buying, we are in the same state. If we buy, then our state will change to sell. But as we are not buying, our state will not change because I may choose to buy in the next stock. So my flag value will remain flag, or I can directly mention 1 and I will call array. Now while returning, what I am going to return? Whether buying gives us the maximum profit or do not buying gives us the maximum profit. Just return buy or sorry. Just return maximum of buy or do not buy. That means we are checking both the option. When our flag is 1, we are checking both the options that are we can buy or we do not buy. Then just returning which option provide us with the greater profit. Right? Okay. So one condition done. That means the condition here, that is case 1, where we do not have a stock, we are going to buy, is done. Now coming to case 2, that we have a stock in our hand. Okay. Now coming to case 2, that means if our flag is 0. Okay. If our flag is 0, I have mentioned that flag 0 means we are going to sell or we are going to hold. Okay. So if we are going to sell now, either we can sell or we can wait. If we are going to sell, int sell, as previously I have mentioned, if we are buying, then we are subtracting value of array of I. But if we are selling on that day, that means we are adding the value of array of I, right? Array of I, because if you are gonna buy with X, sorry, If we are going to buy with X, that means from 0, my current profit is minus X. And if we are going to sell with Y, then my profit will be plus Y. So after the entire transaction, my profit is Y minus X, right? So that's it. So if we are going to sell, we are just going to add the value of array of I, plus we are going to call the recursive function, that is I plus 2, comma. Now why I plus 2? Because the constraint itself says that after selling a stock, there is a cooldown period of 1 day. That means, let there be array. If I sell my stock on this day, there is a cooldown period where I am not allowed to buy any stock. Like on this day, I am not allowed to buy any stock and I do not have any choice for this day, right? So rather than moving to I plus 1, if this is I, if this thing is I, and I choose to sell on this day, rather than moving to I plus 1, where I do not have any choice, I directly jump to I plus 2. So after cooldown period, when I move to I plus 2, I again have choice to buy in new stock, right? So that's why this is important part, that I move, rather than moving from I plus 1, I move directly to I plus 2. Now I will call the recursive function, that means 0 as the flag, sorry, it will be 1 as I buy, my state will again change to 1. Sorry, as I sell, my state will again change to 1, so that I can buy. That means 1 means buy. That means after selling, I can again buy a new stock and have a transaction. Okay. So after that, there will be array. Now there is another case. Okay. There is another case where I choose not to sell. That be de-sell or do not sell. That why the situation where I do not choose to sell, it will be a normal recursive call like I plus 1. Let the flag value be normal. That means the next day I can choose to sell. The state will not change as I do not sell, and it will be array. So that means if I do not choose to sell, I will just call a recursive function and I will move the position to plus 1 only. This time it won't be plus 2 because I am not selling. The cooldown condition only applies when I going to sell, right? And after that, I will just return the maximum of sell or do not sell. Here also, when the current state, or when I have a flag, when I have a stock in my hand, I have two options that I have checked, that I can sell the stock on the ith day, or I do not, and I also not choose to sell that stock. So I check both the conditions and then I return the one that provide us the maximum profit. Okay, so this is the plain recursive function that should work. Okay, just let me code the recursive function of part first. Okay, so okay, so let the function, rather than naming it f, let me name it check. It's my style. I name my recursive function as checks. Okay, so let the current position be position. What I need a flag variable that will store the current state, whether I am going to sell or I am going to buy, and then I just require the array itself. Okay, let me first write the base condition. Okay, so I need the length of the array first. Let me first write the base condition, that is if position is greater than equals to n, then just going to return 0, because yeah, because after the we exceed the value of n, we are just going to get an array index out of bound exception. So just handle it here. And then now coming to my choices. If flag is the equals to, sorry, choice 1, that is if flag is 1, that means I'm going to buy and stock. I do not have any stock in my hand, I'm going to buy it. Okay, so int buy. As I am buying a stock, so my buy value will be minus array of I, because as I am buying with my money, my profit from 0, I'm deducting that money because I'm buying. I have not sell yet. Okay, so check. Just going to go to the next position. My flag will change because I have as I have buy a new stock, my flag will change to 0. That I can directly mention by not of flag, or I can directly mention 0 also here, and then array. Okay, and if I do not want to buy anything, or debuy, let's say, it will be just check of position plus 1. My flag will be as it is, and array. Okay, going to return the maximum of buy or debuy. I will check both the choices that I have, and then just return the one that provide us with the maximum value. Now coming to choice 2, that is we are going to sell. If flag 0, that means we are now eligible to sell a stock. We have already a stock in our hand. We are going to sell it. That is int sell. Because now as we are selling, that means we are gaining a positive profit, right? We're selling with we're getting money. So array of I will be positive. Okay. This will be check off position of I plus 2. As I mentioned, as after selling, I have a cooldown period of 1 day. So I am just skipping that day and moving to the next day. That is position plus 2. My flag value will change to 1 again. That means after selling, I'm again eligible to buy from after the cooldown period. I'm again eligible to buy an array. And if I do not want to sell, that is desell. That will be just check position plus 1, going to the next position. Flag will remain same and array. Okay. Here also, I'm going to just return maximum of sell and desell. Okay. Now return just check. Now what is my initial condition? My initial position will be from the 0th day. Initially, what should be the value of my flag? As initially, I'm allowed to buy. As from the start day, I do not have any stock in my hand, and I'm allowed to buy. So my initial state will be 1 that allow me to buy. Okay, and there will be vector as or array. So if I compile, okay, let me check for the errors. Oh, sorry. It will be position. I've changed swap the position with I. Okay, my output is 0. The expected is 3. Okay, let me check for the errors. Okay, array of position plus 2. Hmm. If I buy my array, I get a negative. Then I check for the position of I. There will be my flag will be 0, right? That I'm going to buy. Hmm. If I do not want to buy, then it will be check off position plus 1. There will be flag, and there will be okay. Return maximum of this and this. Else I'm going to sell. That means just I'm going to profit of array of low position. And I'm going to check off position again 1 and array. If I do not sell, then it will be check off position plus 1, flag and array. Okay. Sell and desell. So I cannot currently find what is the problem with this code. Okay, just let me print the value of the position. So this way I can debug. Let me check whether it is passing through all the positions or not first. Okay. So there is a silly mistake that is that I forgot is that rather than mentioning a double equals to here, I just mention when flag equals to 0. So while comparing, I just need to mention double equals to. So there is a silly mistake there. Okay. So let me just remove this debugging line. So now yeah. So I get now the answer matches. I get my highest profit that I can accumulate throughout the days, different days. That is 3. Now coming to the optimization part, like we cannot choose choose to have performing all the defined condition every time that we move to next day, or every time we go to a different day at different state of buy and sell. We cannot perform all the choices. Then the complexity will be exponential, right? And now the given what is the given constraint is 10 to the power 5, right? Big of constraint n is equals less than equals to 10 to the 5. That means we need to complete this in big of n or big of n logging time complexity. So we need to optimize our current approach. That means how can we optimize this? We need to check all our solution, and we also need to optimize. That's where some senses of DP comes in, right? Like there are some days, let's say, in the eye of the day, we have different choices based on our defined states that we comes in. Either we are going to buy on that day means we have 2 choices, or we are going to sell on that day means 2 choices, right? But we do not require to perform those choices every time we move with the same state and with the same index, right? We can have DP to store the state for us, right? We will only compute for each index and for each state only once, and we will store that inside our DP matrix. And anytime in the future, while we get back there, we will just reuse our DP value. Okay, so let me just explain that with a small example. Like, let's say somehow I move to this cell. Okay, somehow. there are some other operation that I performed here, and somehow I moved to this cell. Let the index be I, and my current state be 1 or 0. Okay, let it be 1 or let it be 0 or anything. Then after reaching here, I computed this equation, either this or this. Like it will just I will just buy or do not buy or sell or do not sell. I will check every possible outcomes that I can have from here or choices. Okay. There can be other ways also. Like there are other operations which will also lead us to this cell and same state. And our previous code, what it does actually is that every time I reach here with different states or same state, I'm computing the same thing again and again. So rather than having it, I will have my DP array, DP of n and different state. The things that I required for the previous videos, I've already tell that the, the defined state that we actually maintain during our recursion, like here in this case, that is our position and our flag or the buy or sell state, are the exact states that are required during DP also. So now our DP array, the thing that we require are our position and flag. Okay, so position can have value for ranging from 0 to n minus 1. So the DP matrix value will be n, and flag can have value 0 or 1. So here it will be 2, right? So at any position, uh, okay, so at any position, after calculating this value, that is maximum of cell or decel or maximum of buy or debuy, I'm just going to store that inside of our DP matrix, that is here. So that after at any point of time after reaching the same cell again with the same flag value or the same state of buy or sell, I'm just going to store that or just reuse the value. Okay. So let me just add the DP part in our code. That is, we are going to have a DP, 2D DP actually. Okay, now let me just implement my DP. DP of position of flag. That means after visiting the same position with the same state of flag, if I will just check whether it is already computed or not. If as my initial state I have filled the DP is -1. Here I have filled the initial state is -1. If the state is still the same -1, that means I do not have compared. I do not have actually calculated the defined choices for that position and that state. So just I will compute, and if the state is not -1, that means I have already computed that and stored inside of my DP. So I will just return. I will just reuse the state. And here I will store. Like after reaching position and having value of flag 1, I check for buy, whether I'm going to buy or do not going to buy, and check for the which choice provide me with the maximum value of profit, and actually store it inside of my DP matrix. Position of flag equals to maximum of cell or decel. Okay, so let me just okay, no. So I also need to mention the DP inside of the function call as our parameters changes. And DP, and here also going to pass the DP array. Let me just compile and run. Okay, vector n was not declared. Okay, so value of n is not declared in this. So yeah, let me just submit it. Yeah, okay. So it's done. So let me just tell everything for the last time and conclude it. That is, the at every point we have so the basic thing is that at every index, based on whether we are at case 1, that is going to buy, we have two choices, buy or move forward, and when we are going to sell, we have two choices, sell or move forward. So the basic recursion is based on these two, and after recursion we can, I just already told that every time when we are reaching the same position with same state, we are going to recalculate everything. So rather than recalculating the same state for same position, we are just storing the thing inside of our DP. Okay, so that's it for today. Thank you.
So this was the solution of today's problem of the day. The entire notes for this problem and the video shall be available at K Plus website. You can visit there. The link is in the description and it's also on the screen. The notes and the video shall be available at the library section of the index under the resources tab inside the community section. So that's all for today's lecture. Thank you. Hope to see you soon in the next video.